70-742 Lesson 13, Installing and Configuring Active Directory Federation Services, ADFS. So in this lesson, we're going to be looking at a number of new topics and kind of high-level topics. The last few lessons in this course kind of takes it to another level. Federated services, we're going to be looking at ADFS. We're going to be looking at, what an attribute store is, what a claim is, and how do claim rules and claim providers and claim provider trusts work. What a federated trust relationship is. The federation server and authentication policy, how we utilize a Microsoft Passport, among other things. In our next lesson, we're going to be delving in a lot more detail into the web application proxy, but we'll talk about that a little bit here. So, Active Directory Federation Services. In short, we can say federated services. What does it do? Well, federated services allow one organization to access the resources in another. It's that simple. It doesn't have to be two, it can be within the same organization as well. It allows administrators to configure your single sign-on, that's SSO, for web-based applications. And as I just stated, this could be across a single organization or multiple organizations. Now, just like when we log into our workstations in our classroom, we type in our student ID and our password, we authenticate to our domain. And that authentication also ties into our authorization, and our Microsoft Windows Server domain has single sign-on. That allows us to view network resources, network shares, print to a printer, do whatever on the network without being constantly prompted for your credentials. If you have access, you're simply given access. Understand that traditionally, if users from one organization needed to access a website that was being provided by another, they could do it one of two ways. Well, there could be a whole set of credentials created for the users on that other web application, that other website, and then you would open up the website, you'd have to log in. But here again, here's more passwords, more user accounts you've got to remember. Or the two organizations could create an always-on VPN tunnel between the two organizations, and then establish a trust between the two Active Directory domains. And that would give the single sign-on capability, but it's difficult to set up and it's difficult to maintain. Active Directory enabled applications are what's called claims-based. This is much more scalable authentication model for an internet-facing application. So Active Directory Federated Service is an identity access solution. It allows any browser-based client to access the website with a single logon to one or more protected internet-facing applications. We do this in the classroom. You're doing it today when you log into sso.browardschools.com. And that authenticates you on the Clever website, which gives you an icon to click on D2L, which allows you to seamlessly log into D2L without having to present another username and password. Or click on Office 365 and seamlessly be able to access Microsoft Office, even though that's somewhere completely different as well. These are federated services. An Active Directory federated service configuration consists of two types of organizations: a resource organization and an account organization. The resource organizations are organizations that own the resources or the data that you're getting access to. Account organizations are the organizations that contain the user accounts that are going to access the resources that are controlled by the resource organizations. Now keep in mind that this could all be on the same system. If the federation is being used within a single organization, that single organization is both the resource organization and the account organization. So when you want to create a trust between organizations, you have to define what resources are going to be accessible to the other organization and how access to the resources is enabled. Those user identities, the associated credentials are stored, owned, and managed by the organization where the user is located. This claims-based access control uses a trusted identity provider, and that's what provides the authentication. It issues a token, that is the trusted identity provider. It issues a token to the user, and then that token is what's presented to the application or service as proof of identity. Users can authenticate to the Active Directory that's stored in their organization, just like we do in the classroom, and then we're granted a claim based on that authentication. It's kind of like going to a fair, and you're going to want to ride the rides. Well, you don't pay for each individual ride when you get there. You buy a ticket, or maybe you get a wristband that gives you access to those rides. Well, that's your claim. That's the authentication claim that allows you to ride any one of the rides that's in that fair with that single access that you paid for. Now, to keep those claims secure, we do this all over HTTPS. When we do this, we're using XML. That's Extensible Markup Language. If you ever see a test question that wants to know what type of language is used with SOAP, the Simple Object Access Protocol, it's always XML. Well, SOAP is also used. The Web Services Descriptor Language, it is used. And UDDI, the Universal Discovery, Description, and Integration, is also used. And it also uses SAML. That's Security Assertion Markup Language. It is also XML based, and it's a standard for exchanging claims between an identity provider and a service or application provider. So understand that communication between Federation servers, it's all based on an XML document that stores, remember the X.509 certificate? Well, that's what is stored. That XML document stores the X509 certificate for token signing and the SAML 1.1 or 2.0 token. Now, the Federation services, they use what we call a Federation server, a web application proxy. A web application proxy, it's an optional component. Now, this is something that we usually put in our DMZ, some type of perimeter network. And what it does is it looks at the traffic that's coming in first and determines whether those packets can be forwarded to the internal Federation server or not. We have claims, which we've just talking about, claim rules, and they determine what makes up a valid claim. An attribute store, which is a database, that's our ADDS, and it's used to look up the claim values. Claim providers, that's a server that issues the claims and authenticates users. Now, I understand some of this stuff might be combined. Relaying parties, claims provider trust, and relaying party trust. So let's say we have our own web applications. So we might use a Federation server in conjunction with those web applications. In the example, if the application is running on Windows and it's part of the same domain, you can bypass the Federation server and grant access directly to the Active Directory users. However, those situations get complicated really quickly. So what happens if the application is not running on Windows? What if it's running on Apache or something like that? Or it doesn't support Active Directory domain services authentication? What if the Windows server is not part of your domain? What if you've not joined it as part of your security policy and it does require SAML or web services for authentication or authorization? It could be a larger organization that consists of multiple domains or multiple forests. All different reasons for all sorts of different configurations. So as you can see, the bottom line here is planning. How many times have we talked about this? It all goes back to planning. Plan it out, write it out, discuss it, come up with a game plan, and then create a test environment. See if it works in your test environment. If it works seamlessly in your test environment, then move on to your next phase. But iron all the bugs out first before you try to implement this. You got to make sure that the client and servers can communicate. Make sure that it's being done securely. If you're using that proxy server, make sure you're able to communicate with the Federation servers in the same organization using HTTPS. A lot of different things. This is a high level topic. Make sure that you read through your lesson thoroughly. It requires DNS names for the internal Federation servers. If the user that's coming in is an external user, they also need to be able to resolve the name of the internal Federation server, and we do that through the proxy server. Because they're coming through a proxy server. So we need to make sure that that still is working. So now I may play around with this a little bit for you in my Hyper-V environment, but if we're going to implement claim-based authentication in our lab environment, we have to have 3 servers. And we could use our Lund DC1 because of course it's our domain controller. We could make server 1 our Federation server and server 2 as the application that would use the claims. Now, if we were in our classroom, we would be doing this, but that is what we would do. We'd need to have at least 3 servers. We would install the server role, the federated service role. We'd create and configure a service authentication certificate in our Internet Information Systems. We'd create that standalone Federation server. You can see all the steps here. I'm not going to read the steps for you. I'm sure you're going through your lesson and doing that. So understand that normally as an administrator, you only deploy the application. You're not the one that creates it. For the test environment, you would install what's called Windows Identity Foundation SDK, Software Development Kit. And we would download that from the Microsoft website. There's another number of things that you need for that, and they run through these steps to do that. We're not going to go into that. Maybe if I include part of the lab in this, we will. I may do that as a separate. I'm still hashing whether I want to do that out or not. But these are all the steps that you'll go through. What is relaying party trust? Well, a relaying party trust, this identifies the relaying party, so the Federation server knows which applications can use federated services. It also defines the claim rules from the claim provider, and that's defined on your Federation server. Okay, so when we're issuing this claim, it's based on the account and the access that account's given. Well, where does it find that? It finds that in our Active Directory. So it used the Active Directory Federation Services uses an attribute store to look up those claim values. Our ADDS is already configured as an attribute store by default. But if we wanted to, you could configure a database, another database, or a directory service and that's running Active Directory lightweight directory services. I know it sounds confusing, but basically you don't have to use the ADDS. We have to use certificates. Make sure that you do that, and when you do this, you can use what's called an authentication policy. And this also can incorporate multi-factor authentication. If we're going to do multi-factor authentication, we can also include what's called context-based factors. Context-based is location. So you may say that, yes, your username and password are correct, but you're in the wrong location, you can't get access to this. It's a little bit different way to control authentication. You can do it by network location, authentication state, the device. There's many different ways. Okay, so very popular today is BYOD, and that's bring your own device. It brings in a whole set of complications into cybersecurity. But we do this all day long in our workplaces. People want to have connectivity with their smartphones. They've used an iPhone all their life and they don't want to use that company Android device. Or they've used an Android all their life. They don't want to use that company iPhone. And to accommodate that, the company allows BYOD. Well, how do you allow these devices that are not part of your network, they're not joined to your network, have access to this? You can configure what's called device registration. And this allows users to join their devices to the organization's network without joining it to the Active Directory. This allows you to manage access based on a number of attributes as well. And the trust for that, it's defined as authenticated, managed, or compliant. And for this, hopefully you have some type of MDM, that's mobile device management policy or platform in place. If it's authenticated, it's simply registered, but it's not enrolled in an MDM. If it's managed, those registered devices are enrolled in an MDM. And if they're compliant, that there are devices that are registered and enrolled, and they meet all the requirements of the MDM policy. Mobile device management is a very important factor when it comes to BYOD and wireless devices. Going down the list here, we can also integrate our ADFS with Microsoft Passport. Passport's a two-factor authentication, and it consists of having an enrolled device like your smartphone and a Windows biometric, Windows Hello, or a PIN. Those two factors are an encrypted key stored on the device, and they're combined with that hello or PIN. This allows users to authenticate to a Microsoft account, an Active Directory account, an Azure Active Directory account, or even a non-Microsoft services. It's not the same as your Microsoft account. Don't get the two confused. There was a time, and here in Microsoft world, this happens all the time. Your Microsoft account that you use for your Windows 10 home computer was previously known as Microsoft Passport. Well, it's not anymore. It's a Microsoft account. Microsoft Passport's now something completely different. Yeah, they keep it complicated. But understand that Microsoft account, it is a single sign-on web server developed by Microsoft. So it allows you to log on as well to things. For example, you could use your Microsoft account to log onto your computer. Well, you could also use it to authenticate for your emails. Let's say you have an Outlook account, and then you would also get access to the Office 365 components of that. Lots of different components. We can configure it for use with Azure. So here we're talking about cloud services. We're talking about accessing things in a cloud. It could be a community cloud, it could be a private cloud, it could be a public cloud. Depends on how you've configured those applications, those servers, and those services. Typically, if you're going to be putting that up there, you're probably going to be configuring a private cloud. So while we've touched on a lot of high-level topics here, make sure you read thoroughly how all these different things are implemented. In this lesson, you're going to be covering the Active Directory Federation Services role and how it allows administrators to configure single sign-on not only for your domain-based network access and permissions, but for web-based applications across either that same organization or across multiple organizations without having the users to remember multiple usernames and passwords. This enables you to configure what we call B2B, Internet facing business to business. Understand what claims are, that the ADFS can support a number of different attribute stores, what a relaying party trust identifies, how ADFS can be integrated in multiple platforms, And if you're already running a Windows Server 2012 R2 ADFS, you can't just upgrade to 2016. You have to add 2016 systems to the farm and then remove the older 2012 R2. And then at that point, you can raise the functional level of the farm to Server 2016. I know, high level topics. Make sure you read, understand thoroughly, and you'll do just fine. Thank you for reviewing lesson 13 in 70-742.